We have seen certain definitions of oxidation and reduction, and we have seen the definition of oxidation and reduction based on oxidation state. Oxidation state, which is a state in an atom in a compound system. Oxidation state is compared to oxidation number. So we'll see how to calculate oxidation number of an atom or an element in a compound. So before that, let's recapture. Oxidation is loss of electron, reduction is gain of electron. So oil rig. Substance that cause oxidation are called oxidizing agent. Substance which used for conducting oxidation are called oxidizing agent. For example, oxygen, chlorine, KMnO4, K2Cr2O7, those all things are oxidizing agents. Substance that causes reduction are called reducing agent. For example, carbon monoxide, H2, then lithium aluminum hydride, sodium borohydride. These are example for reducing agent. For reduction, we will use reducing agent. For oxidation, we will use oxidizing agent, which helps to do oxidation and reduction. So, it is called that the number of electrons of an atom appears to have gained or reduced. So, there are certain rules to identify oxidation state of an atom. So, the first rule, the free elements having the oxidation number is 0. Free elements such as sodium, potassium, copper, hydrogen, chlorine, if they are in their free state, that is, which do not contain any charge. For example, if you take the reaction Na plus Cl, in the state sodium is not having any charge. After the reaction only it will get charge. So it is in free state. So such reaction, if an element is in free state, the oxidation number is 0. A free element is an element on its own oxidation number. It is neutral, so it will have neither lost nor gain of electron. It is neutral in state. Rule 2. The sum of all the oxidation numbers in a molecule is 0. So if we consider this molecule, if we add all the oxidation state, for example, if there are some oxidation state for these elements, if we add all these one, we should get 0. The total should be 0. Total of oxidation numbers is equal to 0. This is the rule 2. Rule 3. The oxidation number of a simple ion is the charge on that ion. We know if, for example, if in a compound it is in NaCl and all, or if any charged compounds, if it is a simple ion, its charge is which represent above. For example, in above of Cl it's given minus 1, it is minus 1. For O2 minus it is given 2 minus, so its charge is minus 2. Al plus 3. Similar to that, we have to write. Rule 4. The sum of oxidation number in a complex ion is the charge on the ion total. For example, some elements are in combined state. For example, sulfate, phosphate, ammonia. These all are will be in combined state. They are polyatomic ions. Sulfate, because sulfur and oxygen, 2 atoms are there in one ion. So such ions are known as polyatomic ions. So for polyatomic ions, the charge will be the total. For example, for SO4, we do not consider sulfur separately, oxygen separately. There is total, that is 2 minus. For example, here PO4 3 minus, ammonia plus 1. Like that we have to consider. Rule 5. In compounds contain H, the oxidation number of H is plus 1. If you take any compound if which contain H, then oxidation state of H is plus 1. Here H2O. Then here for hydrogen it is plus 1. HCl it is plus 1. NH4 it is plus 1. Like that. But one exceptional case is there in metal hydrates where it is plus minus 1. Metal hydrates means hydrogen which combined with metal. For example, sodium hydrate, potassium hydrate, calcium hydrate, etc. Where it is minus 1. Only in the case of metal hydrates there is exception case. All other compounds hydrogen having charge plus 1. Rule 6. In compounds contain oxygen, the oxidation number of oxygen is minus 2. And if you take any compound, um, the oxidation state of oxygen is minus 2. For example, if you take magnesium oxide, the oxidation number of oxygen is minus 2 here. Calcium oxide, minus 2. Any compound of oxygen you take, the oxidation number of oxygen is minus 2 except in peroxides. Peroxide like H2O2 and or Na2O2. In all these cases, its oxidation state will be minus 1. And when bonded with fluorine also, it is minus 1. Minus 1. Rule 7. Alkali metals are always plus 1 in a compound. We know alkali metals, they always show plus 1. In NaCl, NaF, any compound you take with alkali metals, the charge of alkali metal will be plus 1. Similarly, for alkalinate metals, it will be plus 2. Rule 9. For halogens, it always will be minus 1. And only one exceptional case, water halogen, fluorine, chlorine, bromine and iodine. Only one exceptional case when bonded to a more electronegative element. For example, compared to chlorine, oxygen is more electronegative. Only those cases it's showing plus 1 oxidation state. Rule 10. Oxidation is a decrease in oxidation number. If we tell a compound which undergo oxidation, when only there should be decrease in oxidation number. Reduction is gain of oxidation number. If there is gain in the oxidation number after reaction, then we can say that the compound undergone reduction. For example, if you take this reaction magnesium plus copper which gives magnesium plus Mg2 plus Cu. Here magnesium oxidation state, it is in free state, so it is 0. Copper plus 2, 0. So we know for the compound it should be 0, 0 plus 2. After the reaction, magnesium became 2 plus copper became 0. So here decrease in oxidation number. Copper decreased 2 plus 2, 0. So it is undergone oxidation. Copper undergone oxidation, magnesium undergone reduction. For example, calculate in some cases you may expect questions like calculate oxidation state of sodium in Na2O. How will you calculate Na2O? So we know in the case of oxygen, it always show 2 minus. So here oxygen is 2 minus. Na2, alkali metals always show plus 1, isn't it? Plus 1. We know for a compound the total value will be 0. So plus 1 and there are 2 atoms. So plus 1 into 2 minus 2 is equal to 0. So plus 1 into 2 equal to 2 minus 2 equal to 0. So our answer is correct. Its oxidation state of sodium is plus 1 in this case. Like the way we can calculate. In KMnO4, if they may ask, calculate the oxidation state of magnesium in KMnO4. How will we calculate? We can calculate like the similar way. It is K is alkali metal, so plus 1. Oxygen always 2 minus. So Mn we don't know. So if we substitute this in the equation, we know overall should be 0. So um, plus 1 and mn we don't know, so we can put x. Where to write? Here I'll write plus 1. We don't know manganese value, so x, and there are 4 atoms of oxygen, so 4 into minus 2 is equal to 0. So plus 1, then plus 1, 4 into minus 2, it is minus 8. So plus 1 um, minus 8 is equal to 0. Plus 1 minus 8 is equal to and x also there, no? So x is equal to 0. So plus 1 into minus 8 is equal to minus 7. Minus 7 plus x is equal to 0. So x is equal to 7. So like this, if we don't know the oxidation state, we can calculate that. So manganese is plus 7 here. Like this method, we should calculate the oxidation number. So you have to remember all the rules. It is very, very important. So we'll see in next class. Thank you.